Hi folks, welcome to The Breaking. My name's Henry, and today, well, we were going to do macros in the USB to CoCo keyboard adapter, but I misplaced my USB to RS-232 adapter somewhere between here and Wall, New Jersey, and I can't seem to find it. So instead, we're going to interface a OLED display to the USB to CoCo keyboard adapter, and that will give us feedback, and that'll probably take up enough time that I probably shouldn't dive into the macro mode just yet, but that's okay, because I don't have much time before CoCo Fest. And we can get this done before CoCo Fest. So that'll be awesome. Let's look at I2C on the USB to CoCo keyboard adapter with an OLED display. The RP2040 we're using in the format of the Raspberry Pi Pico has a lot of stuff going for it. In previous episodes, we've dealt with the PIO, we've dealt with GPIO, we've dealt with the UART. In this particular case, we're dealing with its hardware I2C capability. I2C is a simple protocol, but quite frankly, I don't want to have to deal with faffing about with timings and bit bangings, and I like it that this already exists here. And the reason I2C is what we're able to use is because the OLED display we're going to be using is, well, that's not what I was looking for. That's what I was looking for. The OLED display we're going to use is, in fact, rather a commodity item. These things are cheap as chips. You can get them anywhere, and they come already put together with the SSD 1306 controller. And the SSD 1306 speaks I2C. Now, it also speaks, oops, that's the wrong thing. It also speaks a lot more than just I2C. So, like, you can speak to a 68,000 or 6800 series interface, 8080 series interface. These are like, if I wanted to hook one of these up directly to the 6809 on the CoCo, I probably could because of the 6809 or 6800 interface it's got there. But that's not what I'm interfacing with. Instead, I'm interfacing with I2C. Here's where I'm thankful. This little bugaboo right here already comes with it put together, already comes with the pins attached, and as you can see, I've already got it kind of connected to the keyboard adapter itself, getting ready to play with this whole thing. Easiest thing to do will be to copy over one of our tests. We've got the blink test, we'll copy that over. And make sure that's -R, there we go. We got OLED test there. And I can open this up. Let me make sure that I've got blink.c open. I also want to have cmakelist.txt. I swear, CMake lists is going to be... CMake is a little bit of the bane of my existence. I haven't made a big dive into how CMake works, but it's very potent and it's somewhat just annoying in how complicated it can get. All right. Yeah, setting up a CMake project is a project in and of itself. You need to make files for the CMake files, it seems like. Recursion. Okay, so to set this up, I know from my example, the example actually doesn't tell me what I need to do with CMake list, but I know that I do need to set up the target link libraries. No, that's fine where it is. Add extra out. Yes, I need to set up the target link libraries. I need to add something in here, and it should be, let's see, does it do I2C? No, it doesn't have any suggestions, but I do believe it's hardware I2C. That should do it. And we also want to print this example to standard output, so I need to add in a standard output initialization, which is along the lines of, there. That should take care of most of what we need to do in cmakelist.txt. So I2C reserves some addresses for such special purposes. We exclude those. And looking back at this code, there's some things that I don't need. And there's my blink. Good enough. I know this is complaining. It will stop complaining once we do our compile. Or once we run CMake. Actually, I should be able to just do a compile. Let's try it. Compile. It's happy. All right. So it's happy with the compile, and as expected, that made that problem go away. Nice. Got the delay in milliseconds, NDEF. All right. So the LED in it, I'm not that terribly worried about, but here's where I will start setting up our code. SDA and SCL are set up with pins on the Pico, that's 16 and 17, which are GPIOs 12 and 13. And those default to different pins. If I look that up, SDA defaults to 4, SCL defaults to 5. According to this, SDA needs to be on 12, SCL needs to be on 13. Let's fix this. That did exactly what I wanted it to. That was really flippin' awesome. I like this. I'm going to have to remember this for later. Now, there's one other thing that I want to define because we are using the default, I believe we're using the default, let's see, I2C default. So let me see what I2C default comes up with. That comes up with I2C 0. Let me make sure that I2C 0 is the one we'll be using. I'm on pins 12 and 13, and that does do I2C 0, SDA, and SCL. Beautiful. Now I'm looking at one other thing, reserved addresses. I2C reserves some addresses for special purposes. We exclude those from the scan. So I will this example will use I2C 0 on the default SDA and SDL pins. We've already redefined those, I2C init, and instead of I2C default, I will use, and then we've got our GPIO set functions. And we've seen this before in other locations. We just are setting up which pins do what, and SDA and SCL require pull-ups, so we're setting pull-ups on those. And now we run the bus scan. This is actually fairly simple stuff. All right, so here's where I'm interested in what's going on. Perform a 1-byte dummy read from the probe address. If a slave acknowledges this address, the function returns the number of bytes transferred. If the address byte is ignored, the function returns -1. So, the slave acknowledges this address, the function returns a number of bytes transferred, which will be either 0 or non-0. If the address byte is ignored, the function returns -1. Got it. I see what they're doing now. All right, this now begins to make a little bit of sense. Ah, okay, it doesn't like that. So I do need to make sure it doesn't have a space there, right? Yep, okay. That's one place where white space is significant, is in the preprocessor. So I'm not sure what that does, but in the example, it says it's false. It does not want the master to, let's see what, it says it does not want the master to retain the control of the bus, so no stop is issued. We do want to issue a stop, apparently. Let's compile that and see what we get. Compile worked fine. And I2C bus scan shows us at address 3C, we have something connected. And if I look at what's happening on the Pico itself, yep, we are in good shape right there. Everything, we've got sign of life happening. The OLED isn't doing anything because we haven't asked it to do anything yet, but the LED is blinking and the OLED has been detected. Good. So now what about actually putting graphics on there? Well, there does exist an example setup in Pico examples for the SSD 1306. We can borrow this code, well, actually just like wholesale copy it over and start using that. But first I want to see what's actually going to happen with this OLED. Let's grab that and get it running. Okay, I see what happened there. It doesn't like the directory I'm in because that directory has a space. It appears to be working just fine. Okay, there we go. Now, to actually build the OLED example, close that. And let's see what winds up happening. Absolutely nothing. Well, let's get into the code there. Aha. I'll bet you nickel this is a problem. So I'll need to redefine those. And I should be able to quit out of that. And we should be able to do a make now. Lovely. And we'll bring that in. We'll put that over there. And let's see what we've got if I use. And we have the OLED display showing the demo. All right, so we know that the OLED works. We know that the interfacing works. That's all good. Now it's time to pillage this code for things that we need. So the render area structure is going to be quite useful for us, as this structure gives us start, end, start page, end page, so that when we spit data over to the OLED, we set its column address, like the start and end address of the display data RAM. Let's see, and then the page start and end address, so that this is what winds up happening. It does it CRLF, it does it CRLF to the start address, and it only goes as far down as the number of pages we've described. That makes things a little bit easier. Now, I'm sure I could optimize this code a little bit, but we're just straight copying here. So I'll just grab this and put it in there. Okay, yeah. I forgot about that. I need to make a change in CMake list because I forgot to put in, let's see, that's got that, SDKNet, version UART target length libraries. I need, I think that's what I need. Let's try that compile again. It did not, oh, that's why I didn't like that. And let's try that compile again. Seemed happier. Let's try it again. Yep, it's happy. All right, so everything checks out so far. Let's see if it compiles and if it complains. Oh, it complained a lot. Oh, I need to use a standard library, and I need to fix a couple of things. Let's get back over here. Oh. Okay. Now, is it still? It's still going to complain because I probably need standard library.h. It doesn't like memcopy. Let's trash that and let's try again. Oh no, it's perfectly fine. Standard library fixed it. Okay, but that does mean that it did go through to compile those, which means that it's available. We're all good. That library is ready to go. Now I just need to add it in. So now on to testing. First, let's get the I2C initialized along with the OLED display. that should take care of getting our OLED display started. And as a first test after getting it started, I want to blink the OLED. So coming down here to LED tab, let's see. There we are. This is our sign of life function. And I want to put something on the, I want to just blink the OLED. Let's see what's going on with that. That should work. Let me check my overhead, make sure we're zoomed in appropriately. We are not, so let me fix that. There's that, and let me compile this. And let's see what we're looking at. All right. It's working perfectly well. A bit out of focus, but it's working perfectly well. See if we can do something. There, that looks much better. And also we see that obviously the GDD RAM, the graphics RAM, has not been cleared. So we're going to need to clear that. Let's work on that one next. I need to get a buffer going that will clear that screen. So I'm still very much not happy with this. Where'd it go? Oh, here it is. I'm really not that terribly happy with the way this send buffer works. And I'm really not that terribly happy with the fact that I have to set up an area and a buffer, and both of those happen. I think we'll switch that around just a little bit. And the question is, how am I going to do that? We've got a UART. Everything in our structures is UART 8T because those are the things that are actually being sent over I2C. So I can use a packed. I wonder if I can use packed. I'm not sure if it'll let me do that. I'm gonna try. What's the worst that happens? It yells at me? Okay. It'll compile. It did not like it at all. Let's try that again, just to be on the safe side. Did I not save? Let's see, I2C.C. That's saved out. What's the problem? What are you griping about? All right, let's try this again because is Calic not in? All right, now it's happy. I don't know why it's not finding these things, but it's not finding these things at first. But now it's happy. All right. Let's, whoop, yep, that's fine. That can be closed. So, let's see what we get. It's not happy. Something went awry. Okay, well, rather than worry about it, I'll just go with what I know works, which I don't find it to be the optimal solution, but I'll go with the solution that I know works. Okay, or that I think that I've seen work before. This moved over here, center screen, overhead. Beautiful. All right, it cleared it out completely. That makes me happy. That frame rate issue is a little bit wonky. So again, if you're used to seeing these kinds of things on video, what the camera's picking up is doing, it's not quite syncing properly with the OLED screen. The striping that you're seeing is not actually happening in, from what I can see. I want to send a column to it and just like set this up. So we've got the blank screen set up. Render area, what that did, that set up the start and end column and the start and end page. If I pull up, I think I've already gone over this, but if we look at the data sheet, that shows us that what we'll be doing is we're starting at the column, we're starting at the start column, moving to the end column. And the way this is set up, it's CRLFing, start column, end column. And in this particular case, come on, out of the way. We've set up the start column and end column so far to be 0 and 127. So the beginning and the end of the screen from right to left, from left to right, and then the beginning and the top and bottom of the screen from the top and bottom of the screen from top to bottom. So next, let's see about putting a column on there. What's supposed to happen is if I send it a data byte, if I just send data, it should automatically progress everything, which is what we saw it doing with the clearing, but I'd like to do that a little more on purpose, just to see what's going on. So we'll get rid of this blank here. Okay, let's see what you're going on about. Oh, I forgot the semicolon. That'll do it. Now it's happy. And go to overhead and see what it does. All right, that's exactly what I wanted to see. And that's good to know because that means that I can send an array literal into some of these functions. Much happier than me. Good. So we know we can send that. We know that it's automatically incrementing. And as that works its way across the screen, we should see it do it basically a CRLF. Okay, did the CRLF. I'm going to call that good. With those done, what I next want to do is I want to put actual graphical elements on there. The way the GDD RAM is put together, the most significant bit is at the bottom of that particular column, the least significant bit at the top. So what we're normally used to is that is if we've got bitmap graphics, it goes from left to right, top to bottom, and each byte takes up n pixels, where n is the number of bits per where n is 1 over the number of bits per pixel. So if you've got 2 bits per pixel, each byte gives you 4 pixels across. in RG6, or also known as P mode 4, you've got 1 bit per pixel, so that gives you 8 pixels across on the CoCo. This, however, is set up so that 1 byte of RAM maps up what they call a page. So the most significant bit is sitting here towards the bottom, and the least significant towards the top. So you effectively take your how are you seeing this? Okay, I've got to reverse this then. You take your left to right, and you flip it. Is that correct? Yeah. Yeah, that looks correct. That looks correct. I'm sorry, I'm looking at my image. So if you're starting here and your most significant bit is here on the left, and you're moving to least significant bit on the right, which is what we're used to in bitmap graphics, you have to take that byte and you have to flip it so that the most significant bit is at the bottom and it moves to the top for the least significant bit, and that's going to work its way across the entirety of the width of the page as it's calling it, which it's not that difficult to do, really, if you stop and think about it. So for instance, let's say that I want to create a little graphic here. Let's say that I'm making an indicator graphic for whether I'm in mapped mode or whether I'm in raw mode. Let's start with raw mode. Well, if I'm in raw mode, then I know that the 2 has a quotation mark above it, and that the @ is on its own key. So let me start by putting some text down here. So again, this will be our most significant bit. If I'm looking at this right here, oh, Control Z that. This will be our most significant bit. As we move up, we will be lowering in significance. This page is our first page that we will be presenting. So that means that I've got a very simple 08. How many of those do I have? It looks like I've got 5. 1, 2, 3, 4, 5, and then I've got a couple of O's, and then 1, 2, 3, 4, 5. That will take care of that line. The next line will be, that is a 0F, that is a 7F, that is a 7F, 7F, 0F, and again, and we move down to this. We've got 3 zeros, and then 1, 2, 3, 4, 5, 6 80s, and oh, I screwed that up. These are supposed to be 80s. Okay, let me make sure that that was supposed to be, yep, 0F, and that's correct. So in this particular case, we've got 80, and that we've got 1, 2, 3, 6 of them. And then the rest of them are zeros. For this, we have, it's going to be a 1, 8, 9 ABC. So that's a 1C, and that will be a 1E, that will be 1F, and that will be a 1F, and that will be a 07, 03, 03, 07, and that will, oh no, that's not a 07, that is an 87. 87 right here. That will be an FF, that will be an FF, that will be an FE, that will be a 7. Nope. 7C. Good enough. And that's transmission it over. It's a little bit tedious, and I'm sure I could automate it if I wanted to. But I'm not going to bother this time because it's really, I mean, the amount of time I'd spent automating it is probably a bit high anyway. You've seen me do this before in another video with a different situation. So that's great. We can leave that as it is. And I will take this. We'll move that over here. Get this out of the way. And let's see if we can't Sprite H. All right. Make sure nothing broke, and nothing broke. Good. Not that it's going to make any difference right now, but nothing broke. So I want those graphics to show up when we initialize. The first thing I'll want to do after blanking the screen, since we start up in raw mode, I will show the to quote with the at. I will borrow these because now I want that to switch whenever we switch between the raw mode and the render and the raw mode and the mapped mode. Compile and see if it made it. Yeah, oh, it worked. All right, everything's okay. Do we have something working right off the rip? Won't that be amazing? Here. Let's get the overhead. It's in good position. To quote net. Lovely. So, what that means is I can now take this and connect it up to the CoCo. Let's bring the CoCo up. And turning the CoCo up on, we see we've got 2 at showing. Now, this should be, let's see, Oh, you know what would help if I'm going to use this keyboard is to actually plug a keyboard into it. So let me get that done real quick. And do I now have? I do. And that's on. Yep. There we go. And we've got ads. Lovely. Now, if I hit Command Z, or not Command Z, Command Z. Oh, Sookie, that's I forgot. Oh, and I've got an error in that, so that's going to need to be fixed. I see a graphical error, and I see a clearing error. So let's reset this real quick, just to make sure that the 2 at looks right. Okay, so I do have some errors in that graphic, and I'll need to go double check that, which is fine. Stay ready on the overhead. Yep, that looks better. Good. Disconnect that for now. Come back over to the composite input. Oh, nope, center screen. There we go. And the other thing that I forgot to do, that fixes that graphic. The other thing I forgot to do, well, let me see if I can fix the only problem that I saw was with the bracket. And there's my problem with that. That should have been a 0C. That'll fix that. And now I should get rid of you. In both of these cases, I want to clear the screen or clear that little bit of screen. So we will, let's see, blank screen area. That means I need to make those global. Lovely. I don't like having to do that. Compile. All right, it's happy. Let's see if it worked. It's visible. Lovely, that looks correct. Disconnect that. Reconnect CoCo, get you back in there. CoCo turns on. We're good. And if I do that, it's not happy. It's not happy at all. Let's see, is anything happening over here? Oh, I'm not getting anything. So something broke. That's usually an indication of something. That's usually the indication. Let's go back here. Turn you off. No, nothing broke. I didn't plug in the flippin'. I didn't plug in a keyboard. And that means that I need to fix some other things. Okay, now the keyboard's plugged in. And if I go to the composite input, I should see Shift 2 gives me quotation marks and the open bracket gives me @ signs. If I go back to the overhead and hit Win Z, that's not right. That's definitely not right. That looks very, very wrong. How did I screw that one up? Oh, well, there's one of the problems, I think, is I appear to be missing 5 bytes there. So I need to fix that. Let's just get that whole thing right back over here and grab you guys just like this. That may have been the issue. Can be seen. Turn on the CoCo. Everything's fine. If I hit Win Z, I still have... I've got a missing bit in the @ sign somewhere, and I've got... That's not a 6E. That is a 3E. There's my problem. That looks good. If I hit Win Z, it looks good. Graphic looks... Oh dear. I'll bet you nickel I didn't change those things around. There we are. No, I thought I did. If it's in the map mode, then I should be in the 2 @ buff and the 2 @ area. Bracket buff, bracket area. If mapped mode active. Mapped mode is a function and is non-zero when accessed as a pointer, which is what I was doing there. It checked to see map mode. It checked to see whether or not mapped mode was non-zero, which being a function, it's non-zero. Okay, this should fix it. There we go. We've got that. What's the overhead show? We show the two at. Okay, or we show the two quote with the at sign. No, center screen. I want composite. There we go. Shift 2 gives us a quote, and that gives us at sign. Lovely. Now, if I overhead and do a WinZ, nice. Okay, Shift 2 gives us an at sign, and we have brackets. Nice. Go back to the overhead, hit WinZ again. It switched back. Composite input. Shift 2 gives me the up, and the bracket key gives that. That's what it's supposed to do. And if I go back over here and just kind of read, nice. WinZ does switch it. It's switching the map. We have indications available to us through the OLED display through I2C. That makes me happy. That took a long time. Well, that took a lot longer than I was expecting. Still quicker than waiting for Amazon to get those UART to USB adapters, though, and that's a little bit annoying because I was expecting those a while back, but they just didn't show up. At any rate, I've got this ready to go for CoCo Fest. That's awesome, and if you're watching this day of release, come over to CoCo Fest. You're going to have some fun. Let me tell you, you will have some fun. If you're watching this day after release, again, come to CoCo Fest. You're going to have some fun. Be that as it may, I want to say thank you so much for viewing today. Be sure to like, share, and subscribe. All this stuff will be on the GitHub with the links in the doobly-doo to get to the GitHub repository for this. Feel free to make one for yourself, or if you don't want to make one for yourself, let me know. I'll make one for you. Thanks, folks. Have fun. Main controls.